In this video I posted half a year ago, I tested UniFi access points with a Intel BE200 Wi-Fi card about MLO support. At that moment, my phone didn't support Wi-Fi 7 yet. Today, finally, I upgraded my phone to Pixel 10 Pro. Let me see how it works with UniFi access points on Wi-Fi 7 to see whether the MLO works and how it works. Okay, let's get started. I have already connected my phone to the UniFi SSID, and from the frequency, you can see it's showing 3 Wi-Fi bands together. Then from the UniFi application for clients, I can also see this phone is showing all 3 Wi-Fi bands here, and they are all green. On the phone, if I run UniFi Wi-Fi man, see, from the signal strength view, I can see 3 Wi-Fi bands. Interestingly, maybe Ubiquiti never thought of 3 Wi-Fi bands showing up together at the same time, so the color choice is not very good, so you can hardly tell the difference between some of the bands, but at least we can see all of the 3, they are showing up together. This type of displays may give you the illusion that, okay, now the phone is connected to 3 Wi-Fi bands together, and it can aggregate the throughput from the 3 Wi-Fi bands to have an excellent network speed, right? Let's look into that to see whether it's really the case or not. The Wi-Fi 7 standard is still very new. Even though a device claims to support Wi-Fi 7, it may mean totally different things. You may be surprised when you expect it support everything you want from Wi-Fi 7. For example, MLO is a fancy marketing term which is used by almost all the devices to boast their capabilities. But under the hood, there are mainly 3 different ways to support MLO. The most complicated way is called EMLMR, which is multi-radio support. And the other one is very common, it's called EMLSR, which is single radio. There's also another type, it's called STR, simultaneous transmit receive. For different devices, no matter whether it's access point or client, you rarely find the technical specifications about how MLO is supported. The vendors purposely hide the information, so we have to dig deeper to find it out by ourselves. In this video, I will not talk about in general how these 3 things are different. If you are interested, you can watch my previous video. This is my lab environment. I have 2 UniFi access points which support Wi-Fi 7 and MLO, but just to make the wireless frame capturing easier, I'm only going to use this U7-Pro-XGS in this video. If I show you the SSID setting for this underscore MLO, you can see it's only broadcasting using this single access point, and for Wi-Fi bands, I enabled all 3 of them. Then if I go to the access point for the XGS, you can see the detailed information about the 3 Wi-Fi bands. Based on this information, in the lower part of the screen, I have 3 Mac machines. I'm going to use them to capture the Wi-Fi frames for the 3 different Wi-Fi bands. You can see I already set the channel and channel width accordingly. The only thing I want to point out is about 6 GHz. From the UniFi network application, you can see for 6 GHz, the channel width is 320 MHz, the widest one. That's supported by Wi-Fi 7. But you may know, till now, all the Mac machines don't support Wi-Fi 7 yet. They only support Wi-Fi 6E. Yes, they do support 6 GHz, but it only supports 160 MHz channel width. It doesn't matter for this video. The reason is I'm only going to use it to capture the wireless frames, and I'm only interested in the Wi-Fi frames which happened during the association, the initial connection. And you may know for the association process, the activity happens within the 20 megahertz or 40 megahertz range. So 160 megahertz is already wide enough. Okay, just want to explain that so we will not lose any frames which we are interested in. Having said that, let me start capturing in all the 3 Mac machines. Okay, then from the phone, let me disconnect, then connect again. Okay, here you see a symptom, which is even though I have 3 Wi-Fi bands enabled on the access point for this SSID, it doesn't guarantee every single time the client will use all 3 of them. So the client will, based on its own capability, the air signal strength at that moment and the access point's response to dynamically decide how to connect. So you can see this time it's only connected using 2 Wi-Fi bands, right? So let me disconnect, try again. Okay, see, it's still 2 Wi-Fi bands, but 2 different ones, right? Disconnect, try again. So let me keep trying. Okay, so after maybe 5 tries, finally, I connected using 3 Wi-Fi bands, right? Now, I believe I have captured all the required Wi-Fi frames I need. Then I can stop the capturing in the 3 Mac machines. Okay, in the 3 Mac machines, I have already opened the captured files for the 3 Wi-Fi bands. There are a lot of frames captured in each of them, and most of the frames are not even related to my home. They were from my neighbors. So just to focus on what I want to check, let me first filter on the 4-way handshake frames. Okay, you can see only the 6 GHz file has the 4-way handshake packets. And if you count how many of them we have, so we have totally 5 sets of 4-way handshakes. Why 5? Remember, we keep trying on the phone, so we tried totally 5 times. Then we end up with all 3 Wi-Fi bands, right? So that's why there were totally 5 authentication processes, right? That makes sense. However, the surprising thing is, you may remember for some of our tries, the end result even didn't include 6 GHz, right? For example, for some tries, we ended up with 2.4 GHz and 5 GHz only. However, the association process, the Wi-Fi authentication process, still happened on 6 GHz. That's one surprising thing. I just want to point it out. We just need to focus on the 6 GHz captured frames for this video. Then, because the 5th try, the very last try, we end up with the situation we need, right? So let me click on the message 1 of the 4-way handshake for the last try, then remove the filter. Okay, now we can see the association packets and the beacon frames we want. Let's start with the beacon frame. So this is what the access point advertised on the air about this SSID. If we go to the details, let me expand the last section about wireless management. Go to the tagged parameters, then go to multi-link section, see the common info, and I'm interested in these 2 sections, EML capabilities and MLD capabilities. For EML capability, here we can find one crucial piece of information we need, which is EMLMR or SR support. So you can see for SR, single radio, is true. For MR, multi-radio, is false. So this confirms this particular UniFi U7-Pro-XGS access point, it does not support EMLMR. It only supports EMLSR. So that means regardless the capability of the Wi-Fi client, the access point itself does not support EMLMR, which is the best but also most complicated one. Okay, let me show you the association request, which is initially sent from the phone to the access point. Let me find it for you. See this green frame? Click on it. Let me expand to the same section. If I go to EML capabilities, the phone, it does support EMLSR, but it also doesn't support EMLMR. Even if my access point does support EMLMR, it doesn't help because the phone itself doesn't support EMLMR. Okay, that's another important finding. Then let's talk about a very important concept, which is MLD. The four-way handshake process is performed at the multi-link device or MLD level, not individually on each radio or band. In fact, this is a key design feature of MLO to enable fast and seamless link aggregation without the overhead of repeated authentication. So in the MLD level security process, there are two different types of MAC addresses. One is called upper MAC or UMAC. This address represents the entire MLD. So for the Pixel phone, it's the single logical identity for all of its Wi-Fi connections. If we check this association request, this is sent from the Pixel phone, right? Under this section, the common info, you can find the MLD address. This is the so-called UMAC. I noted down in the diagram here. And if you compare this MAC address with the frame itself, it has the source MAC address, right? In fact, it's not the same one. They are similar, but the last digit is different. So what you see here in the source address, this is the corresponding Wi-Fi band's MAC address. This is the so-called LMAC or lower MAC address. That's why here in the diagram, I note down the 6 GHz LMAC address as the one we can see from Wireshark here. Then what about the MAC addresses for the other two Wi-Fi bands? They are specified later. Here it says, okay, wait a second, I have sub-element information. So this is the first STA profile. STA stands for station. In this scenario, the STA is the Pixel phone, right? Under this per station profile, you can find the station info, which contains the MAC address. I note down accordingly here. So the first one is for 5 GHz, and then after the first, here comes the second sub-element, and it's for the second station, and here we can find another MAC address, which is for the 2.4 GHz. So in this way, the Pixel phone provides all the MAC addresses, the MLD MAC address and the individual MAC address for each Wi-Fi band within one single frame, which is the association request frame. Then let's check the access points response, which is the association response. You can find it here in this pinkish purplish frame. I can quickly show you the corresponding information, which is in the exact same location as the phone's frame. So it's under the multi-link section. For common info, you can find the MLD information. This time it's for the access point itself. I note down the information on the diagram accordingly. Then in the same way, it provides sub-element information for the other two Wi-Fi bands. So in this association response, the AP provide all the 4 different MAC addresses in the same association response frame to the phone. After this conversation, the access point and the client, they both know the other side's MAC address information. Then they can decide how to proceed with the connection. Okay, then let's try to find out another piece of information, which is whether the Pixel phone can use the 3 Wi-Fi bands at the same time to achieve higher throughput. In the diagram, I noted down several important values I want to show you and compare between the Pixel phone and the access point. So let me show you where I can see them. First, let's check this green association request, which reflects the phone's capability. When it comes to EML, it only supports EMLSR. It doesn't support EMLMR. And this is another important field, maximum number of simultaneous links. So here we see value 1. You may think Okay, 1 means the phone only supports one simultaneous link, right? No, it's not really the case. So according to the standard, this field is very confusingly defined as the maximum number of affiliated stations minus 1, which means if here we see value 1, it means the phone itself supports 2 simultaneous links. Move on to another value, frequency separation for STR AP MLD type indication. So here we see value 31. 31 means it supports multiple, diverse, and concurrent multi-link features. This is an advanced capability that is offered by the phone. However, later you will see the UniFi access point doesn't support so. And then let's move on another field, which is TID to link mapping negotiation support. It refers to the Wi-Fi 7 capability for a multi-link device to intelligently direct specific types of network traffic over different Wi-Fi bands. The negotiation is a key component of MLO that allows for fine-grained QoS management. However, later you will see the phone supports more advanced feature than the access point. The access point doesn't support 3. So we are done with the phone's capability, right? Then let's move on to the access points response, which has the access points capability in this particular frame. Under the EML capability, we already confirmed EMLSR supported, EMLMR not supported. Then here under the MLD capability, the maximum number of simultaneous link, it is 2, which means it supports 3 simultaneous links. You can see finally the access point has a more advanced feature than the phone. So the phone only supports 2, right? Here the access point supports 3. Then let's see this one. Frequency separation for STR AP MLD type indication is only 0, which means it doesn't support this feature. Too bad. Then the last one, the TLD to link mapping negotiation support is only 1. So the access point support 3. So we won't have enough time to talk about the TLD thing. Just from the value, you can see the access point doesn't support the same level of feature as the phone when it comes to this one. Go back to the slide. As you can see, if you compare the supported features side by side, you can see the final agreed feature is just the intersection of these two, right? So which means in the end, what the two parties agree on should be EMLSR, 2 simultaneous links. If you check this table, the final picture is the connection support EMLSR and STR. It doesn't support EMLMR. So this is what we can observe from the captured frames, right? Then let's do some real-world testing to see whether we really see the simultaneous traffic in multiple Wi-Fi bands at the same time. This access point, U7-Pro-XGS, support spectrum analysis. I already launched the spectrum analyzer. At this moment, it's showing the 5 GHz spectrum, and you can see this blue area is for this access point, right? At this moment, you can see the color is green, which means there's no traffic at all. Then in the lower left, I have a Linux machine. Let me see what's its IP address, .1.89. Let me launch a iPerf3 server. Then from the Pixel phone, let me go to a terminal, run iPerf3 client against the left side Linux server, and run it in receiving mode, meaning downloading. Then let me use 10 parallel connections just to maximize the throughput. Then let it run for a long time. Start it. Okay, from the result, it's not super fast, much slower than if you only connect to 6 GHz, right? But this is not what we want to focus on in this video. What we really want to see is whether we see simultaneous activities in the 3 Wi-Fi bands, right? So from the 5G in the spectrum analyzer, you can already see now it's showing green, but in the beginning we do have some red traffic, right? If I go to 2.4 GHz, you can see this area within the dash line is for this access point, and it is super busy. So we basically can confirm, yes, at least 2.4 GHz is being busy doing the traffic, right? But just by checking the total throughput in iPerf, there's no way the system is only using 2.4 GHz because you cannot really reach this throughput just by using 2.4 GHz, right? So it must be using some other Wi-Fi band as well. Then let's check 6 GHz. It's orange reddish, right? So which means the 6 GHz is being used for some of the traffic, right? If we go back to 5 GHz, now it's busy. Again, you can see it's not really static. So sometimes a Wi-Fi band may be busy, sometimes it may be idle. So the system switching among the 3 Wi-Fi bands, but based on our theoretical discovery in the captured Wi-Fi frames, the system can only use 2 simultaneous links. For example, now you can see for 5 GHz, it's not really busy anymore. Okay, it's busy again for 6 GHz. So sometimes it's busy, sometimes it's not. For 2.4 GHz, it's always been busy, right? So we are not really 100% sure just from the spectrum analyzer whether there are 2 or even 3 simultaneous links, right? At least on paper, there should be only 2. Then let me do one more testing. Let me kill this testing for now. Then let me go back to the SSID. So let me only leave 5 GHz and 6 GHz. Let's see when we only have 2 Wi-Fi bands, how the concurrent traffic goes in the 2 Wi-Fi bands. Then you can see the phone automatically reconnected. So now it's only using 5 GHz and 6 GHz. We are good from the connection perspective. Then let me go back to the terminal, run the exact same command. Okay, the speed is almost the same as last time. Let's go to the spectrum analyzer. You can see for 5 GHz, we can confirm the system is doing something, right? And for 2.4 GHz, as expected, it's not busy. So no matter what we see here, they have nothing to do with our testing because the phone is not even connecting to this Wi-Fi band, right? Then if we go to the 6 GHz, not really busy. So it seems the system is only using 5 GHz. So you can see the almost random, unpredictable testing result when it comes to MLO, right? So the client and the access point will work together to find the way they think that's best for that particular situation at that particular time. So you may see all sorts of different results. If your goal is to achieve the best throughput, you may be disappointed by using MLO, even if your phone and your access point support STR, support EMLSR, you may not achieve the same best speed by connecting, let's say, just 6 GHz, right? But that's not the only point to use MLO. MLO has other benefits as well. Okay, this ends the video. Thanks for watching.